All right, today we are going to be learning about solving absolute value equations. So before we work on solving absolute value equations, I think it would be a good idea for us to take a moment to review absolute value. When we talk about absolute value, I want you to think of it as a distance. Absolute value means distance from 0 on a number line. You all are all familiar with the fact that two vertical bars are used to represent absolute value. So if you see absolute value bars with 5 inside, they are asking you to find the absolute value of 5. In other words, how far is 5 away from 0 on a number line? And the answer is, it is 5 spaces away. So the absolute value of 5 is 5. If I ask you for the absolute value of 7.5, then I'm saying how far is 7.5 from 0 on a number line? And the answer is, it's 7.5 spaces. If I do the absolute value of negative 5, then I'm saying how far is negative 5 away from 0 on a number line? And the answer is, it is 5 spaces. So I want you to notice that positive 5 and negative 5 have the same absolute value. They are the same number of spaces away from 0. So anytime you think of absolute value, I want you to think of distance. Distance from 0 on a number line. And what we're going to do is incorporate this idea of absolute value into some equations that we're going to be solving. So in all of the problems that we're about to do, we are going to be solving for x. So our job is to figure out what x is. So we're going to start here. We're going to start out nice and simple. First equation we're going to solve is this one. It says that the absolute value of x is equal to 3. Now, anytime you're solving an absolute value equation, one of the first things that I'm going to want you to do is take a look at what's inside of those absolute value bars. So in this case, what I have inside of my absolute value bars is an x. And this says that the absolute value of x is 3. Now remember here what I said. When you see absolute value, I want you to think of that as a distance. So when this equation says the absolute value of x is equal to 3, what it's really saying to you is that x is 3 spaces from 0. On a number line, okay? So when this equation says the absolute value of x is 3, it's saying that x is 3 spaces from 0 on a number line. So now what I need to do is I need to think about what numbers fit that description. What numbers are 3 spaces away from 0 on a number line? Well, if I picture my number line, with 0 being the kind of starting spot for that measurement, I know that if I go 1, 2, 3 spaces away from 0, that I'll land at positive 3. That is 3 spaces away from 0. So one of the things that x could be is x could be 3. X could be 3. Because if I put the number 3 right here where this x is, the absolute value of 3 equals 3 would be true. Now, I know that's not the only possibility, because I could also start at 0 and go 1, 2, 3 spaces to the left, which would put me at a negative 3. So the x in this problem could also be negative 3. So if I know that x is 3 spaces away from 0, then x could be 3 or x could be negative 3. And you will need to give both of those solutions. Because when we solve for x, we want to give all of the possibilities for x. So I want you to notice that this absolute value equation has two solutions, positive 3 or negative 3. And when you write your answers for these, I'm going to ask you to write them in kind of a fancy way. So you'll notice I'm putting x equals, and I'm putting this fancy brace here. What you're going to want to do is inside of these braces, put those possible values for x. Now this is called a solution set. Okay, the braces that I used here, so these two braces are what tell me that these are a set, and then the solutions are inside of it. So I want you to write your answers in that fashion. I want you to write them as a solution set. So when we're solving absolute value equations, start by looking at what's in between the bars and look at what it says the absolute value is. The absolute value of x is equal to 3, means that x, whatever that may be, is 3 spaces from 0. So then I set about thinking about what numbers fit that description. 3 is 3 spaces from 0, and negative 3 is 3 spaces from 0. So those are my solutions. Now, keeping it simple still, you'll notice this time, inside my absolute value bars, I don't just have an x, I have 3 times x. So let's look at this equation for just a moment and think about what it's saying. If this thing says that the absolute value of 3 times x is equal to 24, then what it's saying is that 3x, whatever that may be, is 24 spaces away from 0. So when this thing says the absolute value of 3x is 24, it's saying that 3x is 24 spaces away from 0. So when I see that, what I need to do is think about where 3x could be. Well, if I'm 24 spaces away from 0, where could I land? One of the places you know you could land is 24. So if 3x is 24 spaces away from 0, then 3x could be 24. Is that the only possibility? Well, no. If 3x is 24 spaces away from 0, then 3x could also be a negative 24. So based on what this equation is telling me, the absolute value of 3x is 24. 3x is 24 spaces away from 0. That means that my 3x that I see inside of these bars could be 24, or this 3x that I see inside the absolute value bars could be negative 24. Now I want you to notice that right now we don't know what x is. We know what 3x is. So what we would need to do at this point is solve each of these equations for x. Pretty simple to do though. We would have to divide by 3 on both sides, which would tell me that x could be 8, or, again over here, same way to solve, divide both sides by 3. My x could be a negative 8. Now, you could check these. You could totally check these solutions. So let's take 8 and plug it in here. That would make this the absolute value of 3 times 8 is equal to 24. Well, we know we would work out what's inside of our grouping symbols first. So 3 times 8 is 24. So is the absolute value of 24 equal to 24? Yes, it is. And then I could take my x equals negative 8 and also plug it in for that x. I'm going to do that right here. So the absolute value of 3 times negative 8 is equal to 24. Now again, we would work out what's in these grouping symbols first. So 3 times negative 8 is negative 24. Is the absolute value of negative 24 equal to 24? Yes. So x equals 8 and x equals negative 8 are the two values that x could have, so that the absolute value of 3 times x can be 24. So again, I'm going to write my solution set. X is equal to a solution set of 8 or negative 8. The order of the numbers that you write in there is not important. You just need to make sure you have both of those solutions. So I want you to notice we've done 2 of these absolute value equations. And I want you to notice the pattern that is already developing here. Most of these absolute value equations are going to have 2 solutions. Because when we know that we are this many spaces from 0, then we can be at 24 or negative 24. There's going to be a positive case and a negative case. And that all happens because of this definition of absolute value that we're operating from. All right, next up, let's take a look at this. We're going to solve for x if we know that the absolute value of x plus 5 is equal to 7. So notice, inside my absolute value bar is what I have. I have x plus 5 inside of there, and I'm taking the absolute value of that x plus 5. That absolute value is 7. So what this equation is saying to me is that whatever that x plus 5 is, that x plus 5 is 7 spaces from 0. So if the absolute value of x plus 5 is 7, then x plus 5 is 7 spaces from 0. So think about what x plus 5 could be. If we're 7 spaces from 0, we could be at 7. So x plus 5 could be 7. Or the other alternative is x plus 5 could be negative 7. So if x plus 5 is 7 spaces from 0, then he is at 7 or he's at negative 7. So we set him equal to both of those values. Now what we would do is solve each equation for x. We know about x plus 5. Now we find out about x. So to solve this for x, we subtract 5. So x could be 2. Or subtract 5 on this second equation, and we find out that x could be a negative 12. So in the equation that we have in front of us, there are 2 possible values for x, and those are 2 and negative 12. If I plug in this 2 up here where I see x, I get the absolute value of 2 plus 5 is equal to 7. Do what's in the grouping symbols first, so the absolute value of 7 is 7. That checks out. Plug in negative 12 for that x. You get the absolute value of negative 12 plus 5 is equal to 7. Do what's in the bars. Absolute value of negative 7 is 7. Checks out. So my solution set for this problem should be 2 and negative 12. So notice what I'm doing every single time. I'm looking at what's in the absolute value bars, and then I'm looking at how many spaces from 0 that needs to be. And then I'm setting up my 2 equations. One is a positive case, one is a negative case. But do notice this. Do notice this. One of my equations says it's equal to positive 7, and the other says it's equal to a negative 7. Do notice that the x plus 5, what's inside those bars, goes in both of those equations. That's common. That's exactly what should be happening here. Now, you'll notice as we go here that all I'm doing as we move up through these examples is I keep adding more stuff inside of my absolute value bars. So I started out with just an x. Then I went to a 3x, then I went to an x plus 5. Now look at where I am. Inside my bars, I have 2x minus 3. Now I have no idea what that is. I have no idea. If I do 2 times whatever x is and subtract 3, I know I'll get a number, but I don't know yet exactly what number that is. But look what this equation tells me. It tells me that if I take the absolute value of whatever 2x minus 3 is, then I will get 17. So whatever this number right here is, if I take his absolute value, I'll get 17. So what that tells me is that 2x minus 3, whatever that number is, he is 17 spaces from 0. So if 2x minus 3 is 17 spaces from 0, then what could he be? Well, 2x minus 3 could be positive 17. That would put him 17 spaces from 0. Or 2x minus 3 could be negative 17. That would put him 17 spaces from 0. So notice again, 2x minus 3 goes into both of my equations, but I have the positive case and the negative case that I have to consider. So I have positive 17 for one of them, negative 17 for the other. All right, so we know about 2x minus 3. We know he could be 17 or negative 17. Now let's see what x is. So to solve, we would add 3, which would give us 2x is equal to 20. And then we would divide by 2, which would give us x is equal to 10. Over here, we would add 3. 2x is equal to a negative 14. And then we would divide by 2. And we would get x is a negative 7. So if the absolute value of 2x minus 3 is 17, if he is 17 spaces away from 0, then the x in this problem could be 10 or negative 7. So again, let's check that out. So I'm going to plug in 10 for x, so that'll make it the absolute value of 2 times 10 minus 3 is equal to 17. I'll work out what's in my group first. So 2 times 10 is 20. So the absolute value of 20 minus 3 is 17. 20 minus 3 is 17. Absolute value of 17 is 17, checks out. Try negative 7. So we'll do the absolute value of 2 times negative 7 minus 3 is equal to 17. I'm going to work in my group first. 2 times negative 7 is negative 14. Negative 14 minus 3 is negative 17. The absolute value of negative 17 is 17, checks. So my solution set for this problem, x is 10 or negative 7. So notice the pattern. Whatever's inside the absolute value bars gets set equal to the positive version of that number, the negative version of that number. We're doing the same thing every time. One last one. And then I want to talk to you about a couple of special cases before we finish this up. All right, on this problem, what are we taking the absolute value of? We are taking the absolute value of 15 minus 2k. Do we know how far 15 minus 2k is from 0? And the answer is yes, because the absolute value of 15 minus 2k is 45. So 15 minus 2k is 45 spaces from 0. So whatever that absolute value is equal to, that is the number of spaces from 0 that he needs to be. So if 15 minus 2k is 45 spaces from 0, what could he be? Well, 15 minus 2k could be positive 45. That would put him 45 spaces from 0. Or 15 minus 2k could be negative 45. Notice again, same pattern. We set it equal to the positive, we set it equal to the negative. We consider both of those options. And now we know about 15 minus 2k, we want to know about k. So let's solve each of these for k. So to solve for k over here, we would first subtract 15 from both sides. That would give us negative 2k is equal to 30. Then we would divide each side by negative 2, which would give us k equal to a negative 15. Second problem, we do the same steps. We subtract 15. That gives us negative 2k is equal to negative 60. We divide each side by negative 2. And we find out that k could be a positive 30. Now again, we could check these out, so let's plug negative 15 in up here. So we would have the absolute value of 15 minus 2 times negative 15 equal to 45. We're going to work in our group first. We'll multiply first. So this is going to be the absolute value of 15 plus 30. Now notice where I'm getting that plus 30. I'm doing a negative 2 times a negative 15. $15 plus 30 is 45, so I get the absolute value of 45 is 45. Absolutely true. Now let's take 30 and put it in for the k. So that's going to be the absolute value of 15 minus 2 times 30. So I get the absolute value of 15 minus 60. When I do the 2 times the 30, 15 minus 60 is a negative 45. And the absolute value of negative 45 is 45. So that checks. So my solution set on this one should be k equals either a negative 15 or a positive 30. So we've done 5 of these now, and hopefully you're seeing that in all 5 the pattern is the same. You look at what's between the absolute value bars and you see how far away it is from 0. And that tells you the 2 things that your expression inside the absolute value bars can be equal to. And you make those 2 equations and solve. Now, most absolute value equations, most, have 2 solutions, just like all of the ones that we've looked at here. But I do need to show you a couple of special cases before I leave you with this. Okay, so here will be the first special case. And then here will be the second special case. So, on this first one, inside the absolute value bars, I see that I am taking the absolute value of x. And this equation tells me that the absolute value of that x is 0. So remember, this is how many spaces x is away from 0. So this says x is 0 spaces from 0. X is 0 spaces from 0. So now I start thinking about what x could be. What is 0 spaces away from 0? Well, the only number that is 0 spaces from 0 is 0. So this equation only has one solution. There aren't 2 cases because I don't have a positive and a negative. I just have 0. So on this particular problem, there is only one solution, and that solution is 0. Because I can only be 0 spaces from 0. Now on the second one, I'm taking the absolute value of x, And negative 3 is my answer. So this says that x is negative 3 spaces from 0. Negative 3 spaces. So here's where I need you to stop and think a minute about the way absolute value works. If I take the absolute value of a positive 3, I get 3, because positive 3 is 3 spaces from 0. If I take the absolute value of negative 3, I also get 3. Negative 3 is 3 spaces away from 0. Distances shouldn't be negative. Distances shouldn't be negative. They are always reported as positive numbers. For those of you who have a GPS, it doesn't tell you to drive negative 3 miles and then turn left. It says drive 3 miles and then turn left. So this can't happen. The absolute value of x can't be a negative number, because we've seen that absolute value takes positives and leaves them positive. It takes negatives and turns them positive. So this has no solution. And to write no solution, you can put that 0 with a slash through it. And it's no solution because I can't be negative 3 spaces away from 0. So look at what's between your absolute value bars. The number over here will tell you how far you want that to be from 0. And that will help you to set up your two equations. That will let you know the two values that it could be equal to. So hopefully this makes sense. If you have any questions whatsoever, then please contact me. We will be adding a little more onto this in the next lesson. We're starting out kind of basic here. So try today's problems. If you're having any difficulties at all, let me know. We can Zoom if we need to straighten out any questions. All right, thanks, and have a good day.